In this video, I'm going to go over some of the key processes that happen in the river basin. We've got lots and lots of key terminology here, so it'd be a really good idea for you to list these and define them so you can use them for revision. It's also really good to annotate diagrams as well. It's a better way to demonstrate your understanding and practice these key terms which come into the storm hydrograph quite a lot, and we need to use them when we're explaining the storm hydrograph. So I'm going to go through the numbers one by one, and then we'll talk at the end about what happens in a vegetated area and what happens in an urban area. So number one, here we've got rainfall, and we often call rainfall precipitation, and we need to call it precipitation because rain isn't the only thing that falls from the sky. We've got snow, we've got hail, we've got sleet, that kind of thing. So we can often call it precipitation, and you can often see this abbreviated in geography to PPT, precipitation. So we need to be aware of that. So the rain starts to fall. So what happens to it? On the left-hand side, I'm going to go through what happens in a vegetated area, in an area maybe in the countryside. So number two, what happens here is that the trees or the vegetation will intercept. It will stop and it will slow down the water. So number two is interception, and that's where vegetation stops the water before it even gets to the ground. And the more interception that we have, then often the slower time it will take the water to get into the river. And if you remember from our storm hydrograph video, you're widening or you're lengthening the lag time, and you're making it less likely that that river's going to overflow its banks and flood. Number three is infiltration. This is what happens when the water hits the ground and it soaks in. So infiltration means that the water has found a surface that is permeable. So that's another key term. The ground can be permeable, and the water can infiltrate and get into the ground. And again, this is lengthening the amount of time it takes the water from when it rains to get into the river channel. Number four is percolation, and percolation happens through the ground. So it's as the water gets into the soil, it's already infiltrated because the surface is permeable, and it percolates through. And again, this slows down the time it takes for the water falling out the sky to get it into the river channel. So that is percolation. Another movement that we can have within the ground is through flow. So number five is through flow. As it percolates down, gravity will take over, and if it's on a slope, a steep slope or not a steep slope, so it will depend, then it will flow through the ground, and we call this through flow. So that's another way that the water will be slowly getting into the river channel. What we've got then is we have got a store of water under the ground called groundwater. And groundwater is what the rocks are filled up, all the pores of the rocks beneath the ground are filled up with water. And this is often where we get our water, or where other places get their water from. And that water can be pumped out of the ground at an aquifer or a pump. So this groundwater also flows, especially if it's under gravity, it flows towards the main river channel. And this is called groundwater flow. And just another point, at the top of this groundwater is something that we call the water table. So I'm just going to add water table because you might see this in an exam question. And the water table is the top of the groundwater. And just another point is that in summer and winter, the groundwater, the level of groundwater, or the level of the water table, which is the top of the groundwater, this can change from being very high in the winter time when we've got lots and lots of rain, to dropping quite low if we've got a time of drought or the water's been pumped out the ground. Either way, the groundwater can rise or fall. During winter time in the UK, the groundwater is often quite high and the water table is quite high. So what that can mean is that infiltration sometimes, even though the ground is permeable, is that the ground is actually saturated. And if the ground is saturated, it means it's completely full of water. So the water will not be able to infiltrate. So it will run off the ground, the surface, as surface runoff. And we'll get to that in a second. So this is what's happening when we've got a vegetated area. When we've got vegetation, like I said before, it slows down the amount of time that the water takes to get from the land into the channel, and probably that river may not burst its banks and cause issues of flooding, etc. What we've got on the right hand side then is an urban area. These are houses. So we've got an urban area, and we don't really have a lot of these processes happening because this urban area will have surfaces that are concrete, tarmac, man-made, and they are often impermeable. So the water will not be able to infiltrate, it will not be able to percolate, it will not be able to flow through the ground as through flow. So what it does, it stays on the surface and it gets into drains and it runs across the surface as surface runoff. So that surface runoff will very, very quickly get into drains, and that will very, very quickly get into the river channel. And that river is probably going to flood, because from the time it takes from when it rains to when it gets into the river, if we link it to our storm hydrograph, the lag time is very, very short. So this is much more likely in an urban area, it's much more likely to cause flooding. If we've got very heavy rainfall on artificial surfaces, we'll very often get flooding, and we'll get the water getting into the river channel really quickly, and that water will overflow, and then we'll have issues, because if we've got a built up area, then that's going to cause a lot of negative impacts in that area of flooding and businesses ruined and houses ruined, etc, etc. So just to recap, in an area of high vegetation, we've got a slowing down of the water, slowing down of the lag time, of the amount of time it takes that water to get into the river channel, so that's quite positive. Well, we've got rid of the vegetation, or where we indeed in a vegetated area where we have saturated land, or we've got maybe clay or a geology that's very impermeable, then we'll get lots and lots of surface runoff. So whether the surface is natural or not natural, if the water can infiltrate, that's great. If the water cannot infiltrate because for whatever reason, soil type or saturation or geology, it's hard impermeable rock, then that water will not be able to infiltrate. So that water will move as surface runoff and will get into drains and into the river channel a lot quicker. So that river will flood.